Okay, so far we've talked about erosion, and then we've talked about transporting materials, and now we want to talk about why would a river deposit materials. And it all comes down to the speed of the river. So in an earlier episode, we talked about what kinetic energy was. So kinetic energy is going to be energy of motion, and so its formula was going to be the energy kinetic is equal to 1/2 mv squared. So it's going to depend on the mass of the particle, and it's going to depend on the speed of the particle. So the more massive it is, the more kinetic energy it's going to have, and the faster it's traveling, the more kinetic energy it's going to have. So that if, as long as the river has enough energy to transport the material, it is going to be transported. And we found out that it could be transported via solution, suspension, saltation, and then traction. But what happens as it starts to slow down? So as it slows down, it's going to start to lose energy, and eventually the river will not have enough energy to be able to transport that material, and it's going to start to settle down. And so on this picture here, you'll notice that you have a river that is making a bend. And you'll notice that it is transporting water. It's also eroding on the outside curve of that river channel, and then it is also depositing on the inside of the river channel. Now later we're going to find out why does it erode on the outside and why does it deposit on the inside. So we'll find out about that later. But the main thing I want you to see is that as the speed slows down, it begins to deposit. As the speed increases, it begins to erode. If the speed is just right, it will not erode and it will not deposit. It will transport. So it all comes down to the speed. So under what conditions will a river erode, transport, or deposit? And it's going to come down to the speed, and it's also going to come down to the mass. So on this graph here, you have the speed plotted up and down. Going sideways, you've got the size of the particles. So that on the left-hand side, you've got the smallest kinds of particles, the clay. And then next to it is larger particles, the silt. And next to that is going to be your sand. And next to that's going to be your pebbles. And then it goes all the way up to boulders. Now you'll notice that the graph is divided up into 3 areas. So the blue area up at the top is going to be erosion. The kind of pinkish whitish area underneath the blue area is going to be the area of transportation, and then the yellow area underneath all of that is going to be deposition. So the 3 things that a river can do is erode, transport, and deposit. And as you can see from the graph, it depends on both the speed of the water and the mass of the particle that is being operated on. So let's start off with the clays. So you will notice that under low velocities, clay is not going to move. And so clay is going to be deposited. All right, now let's increase the speed of the river, and you will notice that eventually the river will get to some speed at which the clay particles will be transported. But notice that it takes a lot of speed in order to get into that blue part where it's eroding. So why would that be true? Okay, one thing is clay is soft, so that it doesn't really scratch very much when it runs into something, and it doesn't have a lot of mass. So that if its mass is small, then that would mean it takes a lot of speed in order to give it enough energy to be able to erode. Okay, now let's take a look at sand. So sand is going to be bigger, and you'll notice that at first, under low velocities, sand is just going to stay put in the river channel. It's not going to move. But as we increase the speed, it starts to be transported. But notice it's easier, it goes into that blue part at a lower speed than what the clay did. Okay, that's because sand is a good eroder. Because sand is going to have more mass and it's going to be rougher. So it's more abrasive. Okay, now let's go over to the boulders. So you'll notice that those boulders are going to stay put in the bottom of the river channel, and they're not going to move unless the speed is really high, because they've got a lot of mass. So they're hard to move. Okay, so it takes a lot of velocity in the river in order to get those boulders to move, but once they do move, they can really erode because they have a lot of mass. And if they're traveling fast, then they have a lot of energy, and when those boulders bump into something, they can cause a lot of erosion. All right, so now we're going to take a break, and we're going to talk about why does a river change as you go from upstream to downstream.